And welcome again to this SimSolid webinar. We will be going through SimSolid live presentation and also a recorded presentation from one of our customers, Don Burr, to give you an idea how they have implemented SimSolid. So briefly, I want to talk a little bit about SimSolid because it is a one of a kind of FEA. It's different, very different actually from all the traditional FEA softwares which we are familiar with. I will then go with a live demonstration showing mainly welded and bolted connections and see how SimSolid handles the workflows and processes. And then we have a recorded presentation from Don Burr, about 15 minutes, well, 12 to 15 minutes, showing a little bit about how they have implemented SimSolid within their organization. And you will see some examples from their clients, and then hopefully we'll have some time. If you have any questions, please type them in and we will go to the question and answers towards the end. I anticipate the presentation to take almost 30 minutes and we'll have about 10 minutes or so afterwards for any questions you may have. All right, SimSolid is not like traditional softwares where you have to simplify geometry in order for the thing to be meshed, because mesh is one of the biggest stumbling blocks for any FEA software where we have to make it somewhat simpler. If we don't make it simpler, then we're going to have problems with meshings and the beauty, and this can take a fair amount of time depending on the complexity of your models. Now with SimSolid, you simply take the geometry as it is. You can export it as a parasolid, step files, or you can even open the inventor files or SolidWorks files and open it inside SimSolid as it is, and it doesn't need to be simplified for various reasons. The biggest reason is that SimSolid doesn't require a mesh, which is very hard to believe because I've spent my lifetime educating customers like yourselves where you have to mesh, and this is the other extreme. So a little bit hard to digest, but that is the big difference. Hence the reason why we don't need to simplify, because it doesn't require a mesh. Now, what you see here is the common stumbling blocks which can create possible headaches, if that's the right word, for our analyses, especially in Nastran and maybe perhaps in SolidWorks and ANSYS, where if you have geometries which have parts, gaps and overlaps, small geometry features, when you have complex assemblies where you have thin parts and thick parts, and also down here the transitions, this one here, where you have very sharp little features, it can create a lot of headache. And typically what normally happens in the workflows, we have to go through some sort of geometry simplification, feature or part suppressions, or in the extreme case, you may decide it's a lot easier to simply represent the geometry as a simple geometry, so you end up doing it again. And depending again on your designs and models, the timing can be from half an hour or so to a couple of hours to days, depending on how complex it is. Now, the beauty is SimSolid is very forgiving and it can handle all these without any headache. Now, I will show you an example which will have some overlaps, so SimSolid doesn't actually care. Now, before I go into the specifics, now obviously we are aware that customers are already using simulation softwares, primarily Autodesk and obviously SolidWorks. We do not anticipate that we want customers to replace. So this is basically a solution which is complementary to what you're already doing. But on the positive side, it is a very comprehensive software. It does a lot what your current softwares do between linear and non-linear, material properties and connections. I'm not going into too much details because what I'm going to focus on is this. So when we approach customers like yourselves, obviously we are aware and we have trained yourself on Nastran, on SolidWorks. We do not want you to replace it. So where is the biggest benefits of this? Now, one of the applications is complex models. These could be, for example, 3D generated parts or additive manufacturers, and something like this is almost impossible to analyze in traditional softwares like Nastran, SolidWorks, and ANSYS because of the complex details. So if you're involved in 3D printing, obviously the future is towards that, lattice structures, organic structures. Generative design is the other one you may be familiar with in the Autodesk portfolio. If parts have been generated as generative design, SimSolid can handle that. Now, the other most common application is large-scale models. This is the primary application for customers and clients like yourselves to take on SimSolid. SimSolid is designed to handle super large models, which can take hours and days to set up and analyze in SimSolid. It could be as complex as you want it to be. I have seen some great examples which I thought could never be handled in Nastran, for example, but in SimSolid, it can be set up and run pretty quickly. Now, this is the example. Well, I'm going to focus the session today on webinars on bolted connections and welded connections. Obviously, if you have been using Nastran or SolidWorks, softwares handle it differently. For example, whether people include welds or not is not so simple. And if you've got bolted connections, can you remake use of bolted connections? I'm pretty familiar with Nastran. I don't think you can do 8 of them. And finally, you'll be amazed, maybe gossamer or paranoia, of how fast it does it and how does it do it. The software runs very, very quickly. And you'll see that when I go to the presentation.